So there's a few methods you've learned for solving exponential equations. Often we take logarithms of both sides. If we have some kind of exponential expression or equation, for example, let's say I have a to the x equals y. I can take the natural log of both sides, which is a common method we use. Why? Because the the inverse properties of exponents and logarithms allow us to write the natural log of a to the x as x times the natural log of a, right? And that's a big deal because we're able to simplify this more complicated exponential expression where the x or the variable is up here, and now we're able to bring that variable down, and it's more of a really a linear equation here if a and y are real numbers. Okay, so that's a little review. That's not exactly how we're going to do this one. There's another method that we've learned that says if we're able to write both sides of the equation with the same base, and then I can just equate the exponents. For example, I recognize that 8 is 2 to the third power, and I recognize that 16 is 2 to the fourth power. So you have to be able to recognize that before you do this approach. And what I'm going to do then is write 8 as 2 to the third, 3x minus 2. And I'll write 16 as 2 to the fourth, and there's a 4x. And then I can use my other properties of exponents by multiplying the 3, multiplying these two exponents, so that's 2, 9x minus 6 equals 2 to the 16x. And now the property I'm talking about is if I have an exponential equation where I have two exponential expressions equal to each other like I do here, 2 to the 9x minus 6 equals 2 to the 16x. And that means these two guys have to be the same thing, right? Which kind of makes sense. 9x minus 6. The exponents have to be the same if everything else is the same, the bases are equal. Okay? And now I have just made my complicated exponential equation a pretty easy linear equation. So that gives me negative, come up here, negative 6 equals 7x, and now I divide both sides by 7 to get my answer. X equals negative 6 over 7. Okay, I'll skip the check. You can check that by plugging it in. You should get the same value on both sides of the equation. So I guess the question is, why did I show you this if we didn't use it? Well, that's often what we do when solving exponential equations. When we're not able, this isn't a very common method, we're often not able to write both sides of the equation with the same base. For example, if I ask you to solve e to the 3x equals 10, I'm not going to be able to figure out how to write 10 with base e, right? So I would just take the log of both sides. And this is probably more common than what we did in this example, okay? But it is another method for solving these exponential equations.